So the first lesson of Unit 1, we will be discussing systems of equations. So systems of equations are a set of two or more equations with the same variables on the same coordinate plane. So one method for solving a system of equations is to graph the related function for each equation on the same coordinate plane. So the point of intersection of those two graphs is going to be your solution. So the point where the lines cross. So you can have three different types of solutions. You can have where you have one solution, so your lines cross at one distinct point. So that means that your lines will have different slopes and you only have one solution. So this is called consistent because there is one solution, and it is independent because there is exactly one solution. Then you have the infinite solutions where the lines are identical to each other. So they lie right on top of each other. So in a way, every single point is a solution. And so these lines will have the same slope and the same y-intercept. So they will have infinitely many solutions because those lines are on top of each other. And so the system is called consistent because it does have at least one solution, but is dependent because there are infinite solutions. So then the last type of solution that you can have is when your lines are parallel. This is when you have no solution. So this is when you have the same slope, but different y-intercepts. So this is called inconsistent because there is not a solution. So for discussion, explain why the intersection of two graphs is the solution to a system of equations. Well, this is because there is a shared point. So that point of intersection is a point that satisfies both graphs. So you can plug that one point into both equations and it works. Okay, so let's go ahead and graph some systems and see if we can find the solutions for ourselves. So for this first system, we are going to have to get these equations into slope-intercept form. So we're going to take 5x minus y equals 3, and we will subtract 5x from each side. And then we will divide by -1. That gets us y equals 5x minus 3. So our intercept is -3. And then we're going to go up 5. So 1, 2, 3, 4, 5 over 1. And then 1, 2, 3, 4, 5 over 1. So we can also go down 1, 2, 3, 4, 5, and then over 1. So there is our first line. And then for our second line, we are going to take -x plus y equals 5. And we have y equals x plus 5. So our intercept is going to be 5. And then we're going to go down 1 and over 1. We are not going down 1 and over 1. We're going up 1 over 1. I don't know what I'm thinking. So up 1 over 1. So I only put in this many dots because I want to make sure I draw a straight line for you guys. You actually do not have to draw this many. So the point where those two lines cross is right here, and that coordinate is 2, 7. So our solution is 2, 7. And to show you what I meant in the discussion, if we put in 7 and 2, then we have 7 equals 7. And then over on the blue equation, the same thing, 7 equals 5 times 2 minus 3. And there we go. So let's look at example 2. So we are going to have to get it into slope-intercept form. So we'll start out with 2y plus 14x equals negative 6. We're going to subtract 14x from each side. So we have 2y equals negative 14x minus 6. We're going to divide it by 2. So y is going to equal negative 7x minus 3. We can go ahead and get that graphed. So we have a negative 3, and then we're going to go down 7, and then over 1. Then we can actually go back up 7, 1, 2, 3, 4, 5, 6, 7, and then back 1. And then, let's see, if we go up 7 more, we'll be actually off the graph. So we'll be about here. And then we have our other equation. So we have to subtract 8x. We're going to divide by negative 4. So y equals 2x plus 6. So we're going to have an intercept at 6. We're going to go up 2 over 1. We can go down 2 and back 1. And so the point where we do cross is negative 1, 4. Okay, so now I want you to go ahead and pause and try this out and see if you can find the solution. Okay, so let's go ahead and take our first equation of 7x plus 2y equals 16. And we are going to go ahead and get it into slope-intercept form. So we'll subtract the 7x. So we will have 2y equals negative 7x plus 16. And we're going to divide by 2. So y equals negative 7 over 2x plus 8. And then we're going to drop 7. And then run 2. And there we go. There's our first line. And then we are going to take our second equation, negative 21x minus 6y equals 24. And we are going to add 21x. So I have negative 6y equals 21x plus 24. We're going to divide by negative 6. So y is going to equal negative 7 over 2x minus 4. So what is going to happen here is that we are going to have two parallel lines. And so this is no solution. So this is what it would look like. See how you have the same slope? But different intercepts.